In this problem, we have a ladder that's leaning against the top of a 7-foot wall. If the bottom of the ladder is 4.5 feet from the wall, what is the angle between the ladder and the wall? We have to assume the wall is vertical and the ground is horizontal. So what we need to do is draw a quick sketch. So there's my hopefully looking vertical wall. Here's my ground that's horizontal, so I'm definitely getting a right angle here. And I have a ladder that's on the ground that's leaning against the wall. So let me try and sketch in my ladder. And now I know that the top of a 7-foot wall, so I know this distance is 7 feet. And I know the bottom of the ladder is 4.5 feet from the wall, so I know this is 4.5 feet. What is the angle between the ladder and the wall? So here's my angle that I'm trying to find. I'm not trying to find the angle between the ladder and the ground. I'm trying to find the angle between the ladder and the wall. Since this is a right triangle, I don't have to use the law of sines and cosines, which we use for oblique triangles. What are the three things we can use in solving parts of a right triangle? The sum of the angles equals 180, the Pythagorean theorem, and any trig function. Well, I can't use the sum of the angles equals 180 because I don't know this angle here, so that's not going to help me find theta. If I use the Pythagorean theorem, I could find this distance, but I don't need that. So see if we can set up a trig function involving theta, 4.5, and 7. So if I look at angle theta, 4.5 is the opposite side, 7 is the adjacent side. So which trig function is opposite, involves opposite and adjacent? That will be the tangent. And we know that the tangent of theta is opposite over adjacent. So I know the tangent of theta. What is the opposite side? The opposite is 4.5 divided by, what's the adjacent side? 7.0. So now to find theta, all I have to do is the inverse trig function, the inverse tangent on my calculator of 4.5 divided by 7.0. Now, since we're trying to find angles in a triangle, the answer needs to be in degrees. Make sure your calculator is in degree mode. And when you put that into your calculator, you should get 32.735 ... degrees. This problem didn't tell us how much to round the answer, so just use your common sense. If I wanted to round it to 1 decimal place, excuse the bad handwriting, theta would equal, that means this place here, the 3 would not affect the 7 because it's below 5. So it'd be 32.7 degrees. And if I wanted it to be to the nearest whole number, then theta would equal, that means this is the place, the 7 would round the 2 up to 33 degrees.